opportunities, the risks, and perhaps some of the ethical discussions around this extraordinary time we live in. So this is part of a summer workshop series. We'll be running questions and answers after the main sessions, and there'll be an opportunity for any clarifying questions after each speaker. So next slide, please. Right, so as we said, this meeting is part of a series hosted by the Centre for Climate Repair at Cambridge. And the Climate Repair Centre here has three main activities. We're looking at deep and rapid emissions reduction, greenhouse gas removal at scale, and repairing damaged climate systems. And this is all feeding into a whole series of activities, urgent activities, looking at solving the climate crisis. My name is Mike Maunder. I'm director of the Cambridge Conservation Initiative, and we are, if you like, the sister organisation to the Climate Repair Group, and we're looking at biodiversity and ecosystems during this crisis. And so it's a delight for me to participate in these workshops and see where the twin crises of climate and biodiversity come together. And having been scarred by all these discussions over climate for years now, what I'm so encouraged by is we're talking about climate and nature as one topic. And that's reflected in the previously really unknown coordination between both conferences of the parties that are planned for this year on climate and biodiversity. So I encourage you to come to the next lot of seminars, and particularly the Refreezing the Arctic series, a core issue and not at all uncontroversial. There's some big issues to be dealt with there. Next one. So we have four extraordinary speakers today. We're going to start off with Nathalie Seddon, Professor of Biodiversity at the University of Oxford, looking at nature-based solutions, promises and pitfalls. Dr. Brian von Herzen, who's going to be looking at kelp and looking at carbon balance. And Brian is a co-founder and executive director of the Climate Foundation. Dr. Damu Shenoy. Damu, welcome, calling us from Goa. And Damu is at the National Institute of Oceanography in Goa and principal scientist of Chemical Oceanography Division. And then we go local with my Cambridge colleague, Shailaja Fennell, and Shailaja is part of the Department of Land Economy and is key in a GCRF project transforming India's green revolution. So welcome all. We've got four extraordinary speakers, each one talking about a key issue related to repairing climate and the role of nature in repairing climate. Next slide, please. So this gives you a little bit of background. We'll make this available to you. You can get some more biographical information on the speakers. Suffice to say they're authoritative in their areas and really looking forward to hearing what they will talk about. So that takes me on to our first speaker. Nathalie, are you willing to start and kick us off? You have 15 minutes to talk, and then we'll do 5 minutes questioning, and then we'll move on to the next speaker.
Yes, that's great. Thanks very much. Can everyone see my slide? Okay, my title slide, Nature-Based Solutions to Climate Change. Great. Well, thank you very much for the opportunity to take part in this event and be part of this really compelling set of seminars in the summer workshop that you're hosting on an extraordinarily timely topic, very live, all of these issues. So I want to talk a bit about nature-based solutions, a bit of about the background to the concept, why it has gained so much traction, and some of the promises that they provide and the pitfalls that we need to avoid. So yeah, I mean, our failure to our failure to slow biodiversity loss or address climate change and the urgent need to stimulate economic recovery without further exacerbating environmental damage really does demand that we very quickly scale up much more ambitious, much more coherent approaches to tackling these challenges. And as Mike said, there's been this growing realization and a real shift in zeitgeist as we've recognized that climate change and biodiversity loss really are two sides of the same coin. And over the last year, lots of evidence around the importance of working with ecosystems, you know, for economic recovery and so forth. But the idea or the concept of a nature-based solutions, this is one such family of a sort of ambitious and coherent approach that has become particularly prominent in international and policy discourse over recent years. For example, here in the UK, the government recently announced its ambition to significantly scale up nature-based solutions in its Leaders Pledge for Nature, which it launched last autumn. And as many of you will be aware, nature-based solutions are a major theme, one of the 5 major themes at the upcoming Conference of the Parties called COP26 meeting to be held in Glasgow in November. But there is an awful lot of confusion around what counts as a nature-based solutions, a lot of hyperbole that isn't always exactly met by the research. And there's confusion a lot around how much of a solution to the climate crisis nature-based solutions can actually bring. So I want to briefly address these issues over the next 10 minutes or so. So put very simply, as shown in this infographic on nature-based solutions here, nature-based solutions are actions that involve working with nature, so working with the natural world to support a diversity of societal goals. What in practice that means is, restoring, protecting, and critically connecting a wide range of ecosystems, a wide range of habitats, both on land and the sea. But nature-based solutions also involve much more sustainable management of our working lands and our seas, our croplands, our timberlands, and our productive aquatic systems. And nature-based solutions, the 4th broad category of a nature-based solution, is creating new ecosystems. And a particularly good example of that is bringing nature into our urban landscapes through green infrastructure. Now, the concept of nature-based solutions arises from the understanding that these natural habitats support human societies in countless ways, from providing food and clean water and shelter to storing carbon and protecting us from the impacts of extreme events, such as droughts, floods, and heat waves, and so forth. It's also grounded in the knowledge that biodiversity loss and climate change share many of the same drivers, and so at least in theory should share some of the same solutions. So we know, for example, that land use change is both the biggest driver of biodiversity declines on land, accounting for approximately 30% declines in global terrestrial habitat integrity. It's also the second biggest source of greenhouse gas emissions, accounting, according to current estimates, for around about 23 to 24%. So protecting or enhancing our carbon stores through the restoration of natural ecosystems can, at least in theory, both reduce warming, or help to reduce warming, we should say, and whilst also slowing biodiversity declines. However, as we've seen, this situation is by no means guaranteed. And what we're finding that some so-called nature-based solutions, so actions are being badged as nature-based solutions, particularly those involving tree planting in naturally treeless habitats, or in a way that replaces intact ecosystems, can have very negative outcomes for both biodiversity and for local communities, indigenous peoples. There is also some critical questions around the timeframes and the spatial scales over which nature-based solutions can help really tackle the biodiversity and climate crises, given the impacts of warming on the health of the biosphere. And I will return to this critical question. But first of all, I want to at a high level at least, outline what the latest research reveals around the key benefits or the co-benefits of nature-based solutions, because it's really important not to lose sight of these co-benefits, and they often are, or are in some sectors at least at the moment. And I think one of the most important aspects of a nature-based solution to keep in mind are the ways in which they can support human adaptation to the climate change that's already locked into the system. There's a growing body of evidence from science and also from practice, because we have to remember that human communities have been working with nature to deal with the effects of climate variability for millennia. And there is a growing evidence base, increasingly brought together and synthesized, that if we implement nature-based solutions in certain contexts, in certain ways, they can reduce not only our exposure, but also our sensitivity to extreme events, so flooding along coasts or heat waves in cities, and by supporting diverse alternative sources of food and income and so forth. So reduce exposure, reduce sensitivity, and critically, they can also increase our capacity to deal with future shocks and changes because, and this is a subtle but very important point, social capital as well as natural capital is built as we implement nature-based solutions, as we restore our landscapes, as we improve our protections of our intact ecosystems. You build social bonds and social capacity, and this has been shown in many contexts around the world to make communities and ecosystems more prepared for and the ecosystems on which they depend, I should say, more prepared for future change. The other thing not to lose sight of, and much has been made of this in the last, quite rightly so, been made of this in the last year, and in view of the pandemic and the need for countries to recover their economies. There are many economically robust reasons for working with nature. And obviously a lot of this evidence was very well and very comprehensively brought together in the recent Dasgupta review. Not going to go into any detail on this here, but I think it's important to frame these discussions with respect to the economic benefits. They're low risk and fairly low cost. So according to a wide range of studies, the benefits of coastal ecosystem restoration, particular mangrove restoration, forestry, recreation, and particularly disaster risk reduction are up to the 10 times the cost of implementation. We know that nature-based coastal defences, to involving salt marshes, coral reefs, and so forth, are between 2 and 5 times more cost-effective than engineered alternatives, although I must stress that in many contexts we need both and hybrid solutions. It's not an either-or, and when I talk about nature-based solutions, it's sort of as a portfolio of solutions to addressing the many challenges we face, and it's important not to overlook that. But there is evidence that in many contexts they can be much more cost-effective. And we know, for example, there's a lot around avoided loss and damage through ecosystems. So we know that salt marshes protect around $23 billion worth of property during the hurricane season each year. And this is increasing, actually. And very critically, especially at the moment, important to highlight that nature-based solutions, of course, also provide a sustainable source of income for local people. And they can generate more jobs than investments in other sectors. And when we think about jobs in nature, we're not thinking about these as short-term jobs. Sometimes people think, you plant a tree and you walk away and that's it. Of course, ecosystem stewardship is a long-term, quite complex process that can generate jobs, in a meaningful and interesting jobs for the long term, as well as jobs in the short term. So, they have a short-term as well as long-term economic recovery potential for investing in nature-based solutions. And so there are lots of figures on this flying around. Particularly good example for every $1 million invested in coastal habitat restoration in the USA, 40 new jobs are created. And this compares very compellingly, I would say 7 for investment and finance, and critically 5 for oil and gas, so 8 times more jobs there for nature-based solution investments in nature-based solutions compared to investments in the oil and gas industry. And another very recent analysis published by Vivid Economics just 2 or 3 weeks ago revealed that although the European Union is only spending 1% of its recovery budget on nature, the job creation potential of increasing that would be massive. So a modest investment, they calculated, of around 3.7 billion euros into nature restoration across just 4 countries would create around, over 172,000 jobs and 7 billion euros worth of economic activity over 15 years. So hugely compelling evidence base growing on the economic benefits or the job creation benefits of investing in nature-based solutions. Now, in addition, and this is where we get to the sort of the core ideas that we'll be discussing in this session today. If nature-based solutions are properly implemented, they can also help to mitigate climate change this century by protecting or enhancing carbon sinks, whilst reducing emissions from land and sea use change. Now, calculating the global mitigation potential of scaling up nature-based solutions to the maximum extent possible is hugely challenging, and all sorts of things need to be taken into account, some of which are extremely difficult to take into account. So we need to take into account all sorts of socioeconomic issues around whose land tenure, all that sort of stuff, plus all sorts of biophysical factors, the effect of albedo, the price of carbon, all sorts of moving parts, all sorts of difficulties and challenges that need to be met when developing these global models. However, there is general consensus among the different groups of researchers across the world who are working on this, that the total mitigation potential of nature-based solutions in the land use sector is at most around 10 gigatons of carbon dioxide per year, or 11 gigatons of carbon dioxide equivalent per year. And according to this analysis that we published in Nature a month ago, 40% of this mitigation potential comes from protecting our intact ecosystem. So not just our forests, but also our wetlands and our grasslands. 20% comes from restoring native ecosystems, but a whopping 40% comes from sustainably managing our croplands and our timberlands. So huge mitigation gains to be benefits there of working more sustainably in our working landscapes. Now, because it's very important to reframe these percentages in terms of the Paris Agreement. I think for a long time there's been a meme in circulation being strongly pushed out there that sort of nature-based solutions can provide 30% of the solution to climate change. Well, it's very misleading. It's actually more like 27%, but that's beside the point. If we talk about 27% or 30%, it sort of is misleading because it implies that we somehow don't always also need the 73% from decarbonisation. So, which we do, of course. So we reframed these figures in terms of the Paris Agreement, and what we calculated was that this 10 gigatons, of carbon dioxide a year is equivalent to reducing global warming by 0.1 of a degree if warming peaks mid-century at 1.5 degrees Celsius since pre-industrial times. However, if we overshoot the 1.5 degree temperature goal of the Paris Agreement and warming peaks towards the end of the century at 2 degrees, there would be more time for the benefits of nature-based solutions to accrue. And if we scale them up to the maximum extent possible, they could reduce peak warming by about 0.3 of a degree Celsius. Now, viewed for a certain lens, you might think, well, that's a small contribution to global cooling, but this contribution becomes hugely significant when viewed in the context of the severe ecological, social, and economic impacts of being in a 2 degree warmer world compared to a 1.5 degree warmer world. If you recall that IPCC report, which set out very clearly the huge consequences of warming to 2 rather than 1.5. Nonetheless, it's important to be very clear that the total potential of nature is much smaller than what must be achieved through the decarbonisation of the global economy. Furthermore, unless we rapidly phase out the use of fossil fuels, the mitigation potential of nature won't be realised at all, because climate warming will undermine the health of the biosphere and its capacity to draw down and store carbon, or indeed provide any other benefits to society. In other words, it's vitally important, we're all saying this, we must carry on saying this, it's vitally important to understand that we have to decarbonise, and we also have to work with nature and scale up nature-based solutions. These are not alternatives. And in this context, offsetting does not work. So, as a result of this growing awareness of the potential for nature-based solutions to address different societal challenges, as I said at the beginning, there's been a lot of traction, a lot of interest in nature-based solutions, but alignment between biodiversity conservation, climate change mitigation, adaptation, and the economy is, as I say, by no means guaranteed. And it depends on sort of 3 real critical factors: whether we keep fossil fuels in the ground, whether interventions in nature are designed to protect or enhance biodiversity, and whether the rights of knowledge of local communities and Indigenous peoples are front and centre of policy and practice. The problem is that these critical factors are actually being overlooked in many cases, and there are 2 major issues at the moment around nature-based solutions. First of all, one, that investing in nature-based solutions for carbon offsetting is distracting from the need to phase out fossil fuels, or if not distracting, then delaying action, and there is evidence to support that. And the second problem is around the overemphasis on tree planting. So the problem is that many high-emitting industries are now investing in tree planting programs to offset their greenhouse gas emissions. This creates this really difficult moral hazard, wherein this misguided narrative that somehow planting a tree is going to help stop climate change is in fact encouraging business as usual rather than drastic scale back of fossil fuel use. So the problem is that these programs often involve commercial plantations of exotic tree species, sometimes established in naturally treeless habitats, or in some cases replacing really important biodiverse forested and also naturally non-forested habitats. And this is really problematic. These often only offer short-term high-risk carbon stores and can have negative outcomes for biodiversity in local communities. And I just want to talk, about biodiversity and the importance of keeping this really, really at the core as a foundational property of nature-based solution, as well as a key outcome. Because clearly for nature to provide all these different benefits to people, the ecosystems themselves that are involved must be very healthy. In other words, their ecological functions must be able to resist and or recover quickly from environmental perturbation from climate change. And we know that there is good empirical evidence that the functional resilience of ecosystems is strongly determined by, well, on the one hand, by ecosystem connectivity, and on the other by the diversity of the ecosystem from the level of the genes, so genetic diversity, functional diversity especially, and species richness across multiple levels in the ecosystem. So as well as being explicitly designed to give benefits to people and to local people, nature-based solutions must also be designed to explicitly support biodiversity. But this is easier said than done in a sense, because the extent to which nature-based solutions can support biodiversity will vary among the different types of intervention. Clearly restoring, protecting intact ecosystems or restoring degraded landscapes to their natural biodiverse state can deliver significant benefits. But the outcomes for biodiversity of, say, creating a whole new ecosystem, such as a tree plantation, will depend upon the species used, the state of the landscape prior to the intervention, and the scale, and this is important, at which biodiversity outcomes are measured. For example, establishing plantations of non-native trees in a really highly degraded landscape might have net positive benefits for biodiversity locally if those trees enable the native ecosystem to eventually regenerate. Or it might be beneficial for biodiversity regionally if that plantation takes pressure off naturally biodiverse ecosystems, carbon-rich ecosystems elsewhere. Conversely, if non-native tree plantations replace intact native ecosystems, such as native ancient grasslands or peatlands and woodlands, which is happening all over the world, still happening all over the world, the outcomes for biodiversity are going to be very poor, and hence the resilience of those interventions is going to be very, very low. But of course, it's not just biodiversity that suffers under these schemes. They're also often bad for climate change in the long term. Although we need wood, and we're increasingly going to need more wood. So we do need wood plantations, there's no doubt about it, and they can support economies locally and nationally as well. So they're important, but they're often not a climate solution, because much of the wood, well, for two reasons, much of the wood often is, for short-lived products. So the carbon gets released back into the atmosphere quite quickly. And also they generally tend to only have one or two species in them. And so they have low resilience to pests, pathogens, and also low resilience to fire. So that's important. The other key issue is that in parts of the world where regulations or regulatory frameworks are weak and land and resources are easily grabbed, appropriated, protected areas or nature-based interventions or plantations, whatever it is, can sometimes be established without respecting local livelihoods or rights or knowledge. Yet these communities often have much, much knowledge on how best to work with nature in their local setting. And in many parts of the world, they are playing an important and critically important role in the biodiversity and climate crisis. I'm thinking in particular, this is true in the Amazon. These people must be therefore making the land use decisions. And if we ignore those cultural links, if we ignore the knowledge, if we ignore these rights, then these initiatives are not only, completely unethical and unacceptable, they are also not going to be sustainable. So they're also, very short term. So to be clear, nature-based solutions, I often say, are these place-based partnerships between people and nature, and there isn't a one solution that can be applied in a top-down fashion. But there are some broad evidence-based principles that can guide investments in nature-based solutions, which is a consortium of research, conservation, development organisations we have been promoting in the build-up to COP26. And they are here. So I'll just quickly go through the four. They build on the things I've already said. So the first guideline is nature-based solutions are not a substitute for the rapid phase out of fossil fuels and must not delay urgent action to decarbonise the economy. The second question is, and the second principle reflects the fact that nature-based solutions involve all ecosystems on land and the sea, not just forests. And it's important to restore, protect, and connect those ecosystems across landscapes for the broad diversity of benefits that they bring beyond carbon, including but also beyond carbon. The third one is very important. I've just mentioned this. Nature-based solutions are designed, implemented, managed, and monitored by, or at least in partnership with the Indigenous peoples and local communities through a process that fully respects and champions local rights and knowledge and generates local benefits. And then the fourth one is the one on biodiversity. Nature-based solutions support or enhance biodiversity. And by biodiversity, we mean the diversity of life from the level of the gene to the level of the ecosystem. So key messages about nature-based solutions and climate change mitigation. To return to that, we think that nature-based solutions make a vital contribution to cooling this century, with the potential to reduce peak warming by up to 1/3 of a degree by 2075. However, this can only be achieved in tandem with decarbonising the economy. Otherwise, warming will turn ecosystems into net sources of greenhouse gases rather than net sinks. And then I've got a couple of points there about the financing. In other words, nature-based solution may be financed in the short term through offsetting schemes, provided that those investing have verifiable, ambitious, credible decarbonisation plans, and that the projects in which they invest meet strict guidelines for good, sustainable and ethical nature-based solutions. Okay, I'll end there. Thank you very much.
Thank you, Natalie. That was a very impressive summary of the issues, and I'm very happy that you made reference to the dangers of inappropriate tree planting. To some extent, we don't need to worry much about them, because I suspect 90% of those trees won't make a year after planting when you look at some of the projects, which is tragic. And I'm delighted also you really emphasized the role of biodiversity, gene level upwards in this challenge. I suspect this is an intergenerational challenge that we're now looking at. This is one of humanity's biggest challenges. We're used to thinking about managing landscapes under 5-year contracts. I think now we're looking at how many more generations do we need to manage these nature-based solutions. Natalie, thank you. We've got time for one quick question to clarify anything that Natalie said. So any questions from the floor? Because Natalie will be leaving us later, so I do want to have at least one question for Natalie. Hold on, I'm just not picking up any of the questions at the moment. Let's have a look. What I will do then is, Natalie, what do we need to get done at Glasgow? What has to happen?
So that's a big question. I think one of the key things is to secure a Paris compliant finance sector. You know, there's a lot of potential finance that could be channeled towards scaling up protection of the biosphere. You know, there's a $500 billion funding gap on nature recovery that needs to be met. It's not going to be met entirely by the public sector, although there's much that needs to be done in the public sector to incentivize ecosystem stewardship and de-incentivize carbon hungry and ecosystem negative activities. But the private sector has a huge amounts to offer, and so we need to be, making sure we're not locking in types of financial systems that are going to continue to erode the climate and the biosphere, and there are various aspects of that. Breaking the link between deforestation and commodities is a big one. Yep. Deforestation is a huge issue. So I think that's one of the major aspects of that, but there are many other parts that we could discuss, but thanks for the question.
Brilliant. Natalie, thank you very much. We'll go on to the next speaker.
I can answer questions in the Q&A as well if people
Oh, that's terrific.
I can see it. I can see things are popping up now. So
things are popping up. Yeah.
All right. Thank you.
That's great. So I'm going to pass the proverbial torch to Brian von Herzen, and Brian is going to talk to us about kelp. For those of you that don't know what kelp is, go on to Netflix and watch the Octopus My Teacher film. I thoroughly recommend it. It will show you the magic of this ecosystem that Brian's going to talk about. Brian, over to you.
Thank you. I hope my slides are showing okay and the audio is working all right. Thank you for joining. I'll be happy to describe marine permaculture and nature-based solutions in the oceans, which complement some of what Natalie was speaking about today. We're very happy to have the support of both Paul Hawkins' drawdown work and also the associated film by Damon Gameau called 2040, which has really done a good job of showcasing the opportunity in the oceans as well as in the soils. So I think Nathalie really resonated an important message, and that is we have to decarbonize 80% or more of our civilization. Once we've done that, there's the opportunity to regenerate ecosystems, many of which have been lost in the marine environment as well as terrestrially, and then ultimately measure the carbon export of those regenerative interventions. And so I'll describe that a bit in the marine environment. Now, the marine environment is really key because, historically, we've been getting a 30% discount on carbon. Of the roughly 1,500 gigatons of carbon that humans have emitted, roughly 500 of those gigatons are in the ocean today. Not only that, 93% of the heat captured by the greenhouse gases are in the surface layers of the oceans, which put marine ecosystems at the very front lines of climate disruption. And that means that coral reefs, from coral reefs to kelp forest, we're dealing with significant challenges in keeping these ecosystems alive, because oftentimes they're living within 1 degree of mortality, and thus being able to ensure their survival means being able to manage their temperatures. Now, this is a recent paper that discusses the trend of stratification in the oceans. And it's a bit of an unusual plot of the oceans. The Southern Ocean is here in the center, and it's actually the Southern Polar Current goes right around Antarctica, and it really connects all the oceans together. We've drawn a latitudinal chart of the Pacific, the Atlantic, and the Indian Oceans. And these red colors signify the increase in stratification in recent decades, where the dark red actually represents close to 5% increase in stratification. This is important because it has a profound effect on the availability of macronutrients and the health and survival of our kelp forests, as well as our microalgae forests. And thus, it's a really important finding that the increase in stratification is here, because the biggest extinction in the history of the Earth, the Permian mass extinction, was associated with stratification of the oceans, deoxygenation, and a loss of 96% of all marine species. To avoid that, we need to really avoid those situations. And yet, I think by some estimates, we're 2 to 5% towards the Permian mass extinction repeat event, and that's a very significant situation. Some of the knock-on consequences are that we've seen a decimation of kelp forests from California to Tasmania. And in particular, these green dots here represent healthy kelp forest in 2008. Yet by 2016, we saw a loss of 90% of that kelp forest due to the big warm blob, El Nino, and quite frankly, climate warming that we've seen on a global scale. So it's a significant problem, and one that we need to address fundamentally. At the same time, in the Western Pacific, we've seen decreases in seaweed farm operations from Indonesia to the Philippines, where something like 60% losses were experienced in 2016, and half of the seaweed farms were abandoned in parts of Indonesia. Similar problems in the Philippines. And so it has a significant impact on the 250,000 seaweed farmers in the Philippines and 2 million seaweed farmers in Indonesia, who are subsistence seaweed farmers living on the front lines of climate disruption. Thus, it's a key opportunity to try to address that. Similarly, for every 1 degree increase in temperature means that we have roughly 5% less marine biomass. This is latitudinally averaged. And so that in the tropics in particular, we're seeing a multiple of that in terms of decrease. And that means that starting in the tropics and the subtropics, but also seasonally in temperate latitudes, we're seeing a decrease in marine biomass with the increases in temperature. And these have profound effects on our marine ecosystems. Similarly, when we look at the carbon flux ratios, realize that in order to stay anywhere close to 1.5 degrees Celsius, we're going to have to look at not only decarbonizing our civilization, but secondly, looking at effective ways of drawing down. And the potential for marine drawdown is similar in magnitude to the terrestrial drawdown that Nathalie discussed. It could approach ultimately similar numbers of gigatons that can be done in terrestrial ecosystems. We like to say once if by land and twice if by sea. And that's one reason we've dedicated a lot of our work in recent years to the marine environment, because it's one that's less studied and less well understood, but it's one that has at least perhaps as large potential as the regeneration of terrestrial ecosystem services. This gives you just an amazing feeling from my perspective of the mass of dissolved inorganic carbon, and that is carbon dioxide, dissolved in the middle and deep ocean today. And it's truly enormous compared to the atmosphere, which is the black box of 860 gigatons of carbon. We have 38,000 gigatons of carbon in the middle of deep ocean, and room for plenty more. And so the problem of carbon in the ocean is not one of the total amount, but one of distribution. And the biological pump does an excellent job of taking carbon out of the surface layers of the ocean and put it into the middle and deep ocean. That also decreases ocean acidification. It's noted that the ocean acidification levels within and downstream of a kelp forest are substantially lower than they are within other parts of the ocean. And thus, the deep ocean represents a vast potential for a blue carbon sink that can be sustained for centuries, if not longer. I like to call this picture Planet Ocean. I'm talking to you from our overseas headquarters in Queensland, Australia, on the left side of this image. And my home state of California is on the other side, on the right. And between the two, there's roughly 100 million square kilometers of accessible ocean area. And according to David Attenborough's documentary, it's mostly empty ocean. And that mostly empty ocean can be harnessed to effectively enable the regeneration of kelp forest ecosystem services offshore in regions that have kelp forests, and tropical seaweeds in regions that have tropical seaweeds. The approach I'm going to describe for you, marine permaculture, is amenable to a wide variety. It's a platform for a large fraction of the 14,000 species of red, green, and brown seaweeds and brown kelps that are available. And of course, the deep ocean stores a vastly larger amount of carbon than the entire atmosphere. Similarly, what is very surprising is that this algae bed and reef plot down here at the bottom shows that we can store up to 15%, actually Flux, we can capture 15% more carbon per square meter per year than even at the Amazon rainforest. And so if we take this highly productive kelp forest and seaweed forests and deploy them in a very small fraction of the open ocean regions, we can in fact have a very large multiplier on the potential primary production that's available to regenerate these ecosystem services initially. Several thousand square kilometers of kelp have been lost already, and then ultimately to increase those over time. Now, there's been work done by a number of authors that discuss the macroalgae forests and the carbon sequestration that occurs naturally. Perhaps 11 to 30% of it does get buried in sediments, but the roughly 2/3 of it, in fact, of the seaweed that does reach the deep sea gets remineralized either by microbes or by macrofauna, and they're remineralized to carbon dioxide, and that deep ocean carbon dioxide then is carried by the deep waters with travel times that can be measured in centuries. These are the few of the locations where deep seaweeds have been discovered at depths of 1,000 to 2,000 meters, and these locations have both brown, red, and green seaweeds that have been discovered in these deep water locations. In particular, we've noted that back in the 1800s, pre-industrially, there were continuous rivers of kelp off the California coastline, extending from central California to Mexico. And today, it's a tiny percentage of what once was. So it's one that's really significant. Now, marine permaculture is an approach where we restore natural upwelling that's been lost due to climate warming. We can irrigate a kelp forest and regenerate this ecosystem that ends up not only growing kelp and the invertebrates that live in kelp forests, but also regenerates fish habitat that is a key to regenerating sardine populations and other forage fishes. So we see this as a really key opportunity. Before global warming, an offshore wind would provide plenty of upwelling to the surface with associated macronutrients, including nitrate and phosphate, being provided to these kelp forests. In a global warming world, the thermocline is deeper, the temperatures are warmer, and it prevents upwelling from occurring at the normal rate. That is a physical barrier, energy barrier, to actually restoring that or returning circulation. But with marine permaculture, we're able to utilize solar, wind, and wave energy to irrigate up to a square kilometer of kelp forest offshore and restore the regional ecosystem services offshore, far enough offshore that they don't impact the coastal environment. And so this is the general approach that we've been using, and we envision both hectare scale and multi-hectare scale marine permacultures in the future that can regenerate kelp forest in tropical to temperate latitudes. And in the tropics, we can use local red seaweeds to do similar accomplishments. These can be partially harvested, perhaps every 90 days, and they can produce food, feed, and fertilizer products. And those products that are not used directly for food, feed, and fertilizer, the residual seaweed, can be sunk to the middle and deep ocean. And we see that as an opportunity to provide a carbon negative and climate positive solution at the same time that we're actually regenerating ecosystem habitat and also providing food, feed, and fertilizer products that are highly essential. The per square kilometer, we're estimating 3,000 tons of seaweed, potentially several hundred tons of fish, and over $1 million in revenues. And ultimately, this fixes approximately 3,000 tons of carbon dioxide per square kilometer per year as well. And so we see the opportunity to sink the residual carbon that's not being used for food, feed, and fertilizer. We can track that sinking past 300 and 1,000 meters. And the event horizon or sequestration horizon is approximately 100 years at 300 meters and perhaps close to 1,000 years below the 1,000-meter depth horizon. So we see that as a key opportunity. And in fact, the carbon to phosphorus ratios indicate that for every upwelled mole of phosphorus, we're sinking several moles of carbon as a result going down. And so these ratios are really substantial for macroalgae, where they have higher carbon to phosphorus ratios, and thus that provides a net benefit to the sequestration for microalgae. We can measure that sinking using a variety of sediment traps that have been established over the past several decades with standard operating procedures. And this illustrates how the deeper we sink the carbon and in the form of seaweed, the longer the sequestration time. And that can be verified by maps such as this, which provides radiocarbon dates of the deep water that provides very accurate maps of the number of centuries of sequestration that's possible. And from this, we can calculate the median time to outcropping of abyssal waters and thus the sequestration time. Past 100 years, the United Nations is prone to give carbon credits. And we see even RPE Mariner has indicated that if this is deployed with several 100,000 units, more than 100,000 units, that potentially a gigaton or more of carbon can be captured at the same time that we can generate agricultural products and increase food security and ecosystem life support. So far, we've developed not only the theoretical framework, but also deployed experiments demonstrating that algae would grow with upwelling, and that this trough-based systems demonstrated the commercial growth of, or the growth of commercially relevant seaweeds under deep water irrigation. We're now working to expand in several stages to a hectare scale. And once that's proven, we should be able to build sustainable industries from Australia to the Philippines to the Mediterranean, potentially, of being able to build and grow sustainable hectares of seaweed and be able to enable those to thrive for years to come, and then ultimately consider going to larger scales. We have, with thermal imaging, demonstrated that cooler water can grow the seaweed. These darker colors are much more productive seaweed compared to the light colors on the right side. And that's produced really substantial growth curves where we're seeing a significant doubling of the weight of the seaweed with deep water irrigation compared to controls that actually lost weight during the same months of the year. And so we see this as a great opportunity both in the tropics and in the temperate regions. We saw 4 times the growth of these mature kelps in higher nutrient zones relative to baseline control kelps. And so we're very encouraged both by our temperate and by our tropical results. So from that perspective, we see that as a key opportunity. This is a short simulation of a 10th hectare scale model of a marine permaculture platform. And it uses solar power, marine solar, to actually do the deep water irrigation. And the seaweeds are located in the outer ring, where you can see some of the radial lines extending and supporting tropical seaweeds in this case, but also temperate kelps could be supported as well. These platforms we see as being scalable and really leveraging a lot of the infrastructure of traditional salmon aquaculture that has been proven to work effectively in seas of up to 10 meters. So we believe this would be highly effective offshore and highly resilient to storms and other challenges that occur from time to time. These renewable energy pumping systems can bring water up from the deep and restore the natural upwelling that existed pre-industrially, and furthermore can provide a sustainable supply of nutrients and overturning circulation that's required for these ecosystems to do well and to thrive. Once these smaller systems have been demonstrated, we believe that commercial hectare scale systems can be deployed, and we're looking forward to assist with that industry. I'm going to try to progress this. So we've summarized the amount of seaweed that we can sink, and the fish harvested, and the carbon that can be sequestered. And with that, I thank you for your attention and look forward to your questions perhaps later in the session.
Right, thank you very much. Extraordinary. I get the impression watching and listening that we're in the next phase of creating a new domesticated landscape. This is an extraordinary sort of frontline in new new landscape development and domesticating a whole new suite of species for our society. Extraordinary. We have time for a quick question for Brian. I'm just going to open up the questions and answers. And yes, I have a question from Spats. I trust that's not your real name. Brian, would seaweed, sargassum, algal biodiversity help? Is there also mussels and oysters? And would you get more fish?
Yes, we've actually explored co-locating the seaweed, the kelp forest permaculture near mussel farms. And it turns out the ammonia that comes from mussels and finfish contributes significantly to the growth of the macroalgae. They soak up the ammonia immediately. They can also absorb nitrate. And so there is a synergy associated with what we call integrated multi-trophic aquaculture, IMTA. And we believe that's going to be really an expansive possibility. And we're currently exploring projects in New Zealand where there's a significant amount of mussel farming and in other locations as well. So we see this as highly synergistic.
Brilliant. Thank you, Brian. Brian, we'll come back with more questions at the end of the presentation. So thank you very much.
Thank you.
Right. Damu, are you ready for your session? 15 minutes and then 5 minutes for questions, please.
Thank you, Mike. Yes, so I hope the screen is visible. A very good afternoon to all. And at the outset, let me thank CCRC for giving us an opportunity to present this technique, which we believe does hold potential for carbon capture. And I'm Damodar Shenoy, and along with me are my other two major co-investigators, that is Suhas and Mangesh, and I belong to CSIR National Network of Oceanography. And in our group, we have a few people. Apart from me, we also have B, Hema, Anil, and Suhas. The group basically focuses on looking at the cycling of carbon, nitrogen, and sulfur in the aquatic environment. And our main focus has been on looking at the low oxygen environments. The group also looks at, we also maintain a time series station of Goa, which was established way back in 1997. And we also had an opportunity to work in the LawFlex program, which was handled by NIO and Alfred Wegener way back in 2009. I missed that particular experiment. I was doing a postdoc then. Hopefully, I think now with this opportunity, I might get a chance to do some work in carbon sequestration. And along with us, we have our partner, Persis Billimoria, who is the founder and CEO of Earth Solar Systems. And he has been actually the main driving force behind this. And he's been the one who's been actually pushing us. And the basic aim is that we are trying to test, say, Clark's hypothesis. That's basically how to use natural buoyant flakes to use it for sequestering carbon in the oceans. Most of us are very well aware of the problems that the world is facing as of now. And but at the same time, I thought we should brush up on a few of the things that we need to show about, because what I'm going to show about will have a bearing on what we're planning to do. So on the right side, what is seen over here is the increasing carbon dioxide, which is very well known. That level has now already touched or crossing 420 ppm, and which is well above the threshold of 350, which was set out earlier. And not only is the carbon dioxide increasing in the atmosphere, it's also increasing in the sea. And on the left, we can see the total change that is brought about in the recent years. This is a recent paper brought by Gruber et al., wherein they show the change in the carbon dioxide in the surface waters and at 400 meters and at 1,000 meters. And you can see that there's been an increase. This increase is looking at between 1994 and 2007. But what's interesting is that the oceans act as a major sink for carbon dioxide, and it's actually removing about more than 1/3 of that anthropogenic carbon. If not for the oceans, the concentrations in the atmosphere would have been much, much higher. And what's doing this job is basically the biological pump and the solubility pump. The biological pump basically acts in the surface layers, and this is where the anthropogenic or the dissolved carbon dioxide is picked up by the phytoplankton and fixed. And this carbon is then transferred by a chain of the food chain and the food web, and it passes to the different organisms that live in the aquatic realm. A part of this is lost to the deep, and this is how, through millions of years, the oceans did a good job of removing the carbon and storing it in the deep. And other part is the solubility pump, wherein the dissolution of carbon dioxide results in the protonation of the surface waters. We now have proof that it's also getting into the deeper waters. And this is basically, as of now, with the observations available, has shown that the surface pH has gone down by around 0.1 unit. And this is the observations. And the models are now predicting that if the present times of the emissions of CO2 continue, by the turn of the century, the total pH would go down by around 0.3 units. The worrying thing about this is that this will have a major impact on the phytoplankton and the major life that is there in the oceans. Not only the calcareous organisms, but the overall plankton itself will have a major problem in sustaining. Basically, we are looking at a change in the ecosystem impact overall in a major way. Now, what controls the algae or the uptake of CO2 by carbon dioxide by algae? On the right, we have the various parameters that is there, right from light temperature to the major nutrients, macronutrients, and also the grazing part. It was nice to see Brian showing how kelp, how are doing their part and what's been happening in the recent years. But then we know that the right from the fixing of or the major summer blooms that happen in the north to the bloom that will happen in the south, it's very clearly known that the nutrients, especially the nitrate, is a controlling factor in the tropics, whereas in the southern oceans, it's mostly the iron. And from this actually came out the basic idea of the ocean iron fertilization. And this basically came out in the 70s. And this actually led to quite a few expeditions. In all, 13 expeditions have happened, and they have been done in various parts of the world's oceans. What's very clear from these expeditions is that if you add iron significantly, you get an enhanced primary production. But at the same time, along with these came the concerns of the harmful algal blooms, the halogenated hydrocarbons, and the greenhouse gases. But later on, we realized that these were just, these were these did not play a major role, especially on the scale with which these experiments were carried about. Now, on one side, while adding iron, we are able to get the enhanced production of fixing of carbon. It is also important. This particular experiments also gave, kind of concreted the idea that we not only do we need to fix the carbon, and we also need to remove it to the bottom. We need to remove it out of the system. And this is what is one of the important takeaways from this experiment. And looking at these particular things, we are trying to test Clark's hypothesis, which is basically to see how the natural buoyant flakes can be used to sequester carbon. And the basic objectives that we have come out with initially in the phase 1 is to test the efficacy of natural buoyant flakes for CO2 sequestration and carbon export to the deep ocean by conducting laboratory and Mesoposium experiments. We've done some laboratory as experiments. We've also done some incubations. I'll show a few of the results to you. And we plan to next go for the Mesoposium experiment, which will be a great thing to work about it. But importantly, once we're doing this, we also need to see what are the adverse effects of such fertilization may bring about, if at all. For example, if there are like noxious blooms or production of greenhouse gases. Before we go to that part, we also need to see what's the basic concept that we are working with. The basic idea here is to use you give iron and silicate in areas which are having very low concentrations of this. And what happens is when you give iron and when you have iron and phosphate available, that basically gives rise to diisotrophy. And with this, nitrogen is getting fixed. And once the nitrogen is fixed, with the help of the rice husks, which is having enough silicate in it, you can get diatoms. So this is the basic idea of the whole, wherein we're trying to find out. So the idea was, the concept was put forward by William Clark, and we are trying to try it out and see how it works out in the lab or in the field. So how do you make these flakes? The flakes are very simple to make, and the best part is that everything that is used over here is natural. The rice husks which are used is again an agricultural waste, and it's got plenty of silicate in it. We are having a lot of mining going on around in different parts of the world, but there are ore rejects, and the companies usually take up ores, if you take the case of iron, with around 50 to 60% or even 40s recently. But there's a huge amount of ore that is not being utilized, and they're usually having iron to the concentrations around 10 to 15%. So we can use those kind of ores or ore rejects. And the third is that you need to combine these two using a lignin. Again, lignin again can be availed from various factories, wherein once they remove the sugars from the straws and the other barks, that particular remaining lignin can be used. And we tried this method, and using this method, we have made the flakes. The basic concept of how to make the flakes is given in the manual given by Save Clark. And on the right side over here, you can see the flakes or branchings over here. And you can make them either as single or as a composite of a few flakes. We have so far worked with the singular flakes, and each flakes have got a size of around 0.3 to 0.5 centimeter square, and they float in the surface waters. So the basic aim is to go out and test. Now, before we wanted to go out, we wanted to see in the lab itself how do those flakes result in terms of releasing the nutrients into the seawater. So we did a few deck and lab incubation. We did some the field incubations in our Donopal Bay itself, very close to the lab. And there we utilized a tank, which is of having a capacity of 150 liters, and we gave it around 120 flakes. So basically it was covering an area of around 0.4%. That's the total percent the flake covered. And on the down below, you can see the results over here. The center line, which is showing here down below, is the silica thing. On the left, we have the blank, wherein you can see the silica getting drawn down by the phytoplankton over a period of around 21 days. On the right side is where we have the flakes in the system. And there you can see the silica concentrations going up between 7 and 13 days. And again, that's been removed out a period of time. So this is from this, it's clear that the flakes actually form a very good component in terms of giving silica or silicate to the system. And this experiment, we then extended to the deck incubation experiments when we go out to do a regular, we have a time series transact in the Arabian Sea, which we sample seasonally. And we utilize this particular opportunity to do a deck incubation in the Arabian Sea, wherein we did simple deck incubations using surface water. And we did them at 4 stations, that is II1, II5, II10, and II14. And we had a control wherein there was a blank, then we had only husk, and the other treatments were having low, medium, and high concentrations of flakes in it. And at II5, let me also tell you that this also already had some amount of trichodesmium in it. You could see a clear increase in the phytoplankton concentration, phytoplankton numbers, which multiplied nearly 7 times. And at the same time, we found a very high concentration of TOC, which is nearly double than what was there in the control. So this was in the Arabian Sea. And the similar experiment in the Bay of Bengal yielded very nice results in the same, wherein we found TOC concentrations multiplying nearly 5 times. So these are some of the field and the lab experiments which we have carried out, which showed very interesting results. But what needs to be seen is that how do we scale up the experiment? And the way to do that, what we're planning is to go ahead and do a Mesoposium experiment. And this we're planning again in the open Arabian Sea during the coming March or April of 2022, because during this time, the region is oligotrophic. And what we plan to do is put around 5 nets out over there, and 1 will be the control. And in the remaining 4 nets, we will have varying amounts of the rice husk, the natural husk. And we would like to see how the entire carbon capture happens in this. And what we'll be doing is we'll be sampling. The net is around 2 meters in length with around 1 meter diameter, and it will be attached to a platform, and it will be kept well away from the ship. So the one of the major challenges would be to do the trace metal part of it. We are already working on it, and we are planning this experiment for a period of around 21 days. And during this time, we'll be sampling twice a day. We'll be taking samples just below the surface and at a depth of around 1.5 meters from the various bags. And we'll be doing it with the help of peristaltic pumps. So we are planning a range of measurements to go along with this, right from looking at the temperature and salinity to looking at phytoplankton and zooplankton. We'll also be measuring plant productivity and nitrogen fixation, as well as pigments. We'll be looking at nutrient uptake, carbon chemistry, both organic and inorganic, and also looking at vertical carbon export. At the same time, also looking at whether there are any gases being produced at the same time in these waters. What we realized is that the enormity on the scale of this experiment is huge. So we need to see, we are already in the planning stage, but we need to see how to exactly work out upon it. What we expect from this is that if the basic aim of this phase 1 is to see how good the delivery system of this flake system is, whether the flakes are able to, once they're able to deliver, what kind of phytoplankton blooms come along with it. So that's one of the major outcomes you're expecting from this, is to see how efficient the flakes are in terms of carbon sequestration, and at the same time whether we get any harmful blooms. Also we get any gases that go along with it. So one of the major anticipation is that this can help. This can be a good tool for capturing carbon. At the same time, if needed, and later on, we can also utilize the same for, as a fish, increasing fish biomass or as a fish culture. So in phase one, basically that's going to go between 21 and 23. We are going to test the efficacy of the delivery system to see how good the flake is in delivering the nutrients. And if it works upon well, then in 2023, we would like to repeat, because depending upon the results we receive in 2022, we can then modify or take the maximum carbon efficiency numbers and then increase or repeat the same in the next year to see how good they are in the next year. So following these two experiments, we can then utilize and put the numbers in a model, but the basic aim is to then go out and do open ocean trials. So as I mentioned earlier, while planning this out, we realized the enormity and the complexity of a simple mesocosm like this. So we are very glad if anybody else wants to participate in this particular experiment, and we are open to suggestions in whichever way we can help improve upon the experiment. Thank you.
Damu, thank you. The complexity is extraordinary, and I'm picking up a theme where a lot of organisms that have been fairly low down on global research priorities are now suddenly coming to the fore, with phytoplankton being one, kelp being another. I have a question actually from Sean Fitzgerald, the director of the Centre for Climate Repair. So Sean says, thank you, Damodar. Are you looking at undertaking public attitude surveys in India regarding this approach? So,
I'm sorry, can you please repeat the question? I didn't get it quite right.
Yes, are you looking at undertaking public attitude surveys in India regarding your approach? So looking at how the public feels about your work.
I think it's a very good question and a very important point, because we know that the ocean iron fertilization has not been taken that well by the public because of the few aspects which I mentioned earlier. But public opinion is an extremely important point, and we need to take it, because the public needs to understand that what's being done. But at the same time, and let me cover one other aspect of this, is that any experiment that we perform out in the natural environment, we need to take it with a little bit of caution, because what we're trying to do cannot be a fix in one go itself. The oceans, the nature has taken millions of years to put that carbon down, and we are removed it out in a matter of 170 years, a good amount of it. And we're now trying various ways and means to fix it. So definitely public opinion is extremely important, because we need to have them on board when we perform such experiments. So that is one thing definitely we feel will be a part of our project.
Brilliant. Thank you, Damo. We'll move on to the next speaker, but there will be further questions. So thank you very much.
Thank you.
I'd now like to... Shailaja, are you ready to take the next stage? Brilliant. The floor is yours. Thank you.
Thank you so much. Thank you. So I'm going to bring us full circle back to the land in a circular process, and also to talk about agricultural practices, ones that have been lost and ones that have been useful in relation to thinking about both carbon sequestration and greenhouse gas reduction possibilities. My work is driven by two major research projects that have been based at Cambridge in plant sciences, and I'm a co-I on them. Tigris, which is looking at a new green revolution or alternative green revolution for thinking of sustainable food in India. And the other one is Milneti, which is a project that is looking at taking these ideas through millets, as I'll speak about in a moment, into West and East Africa. Just very quickly, why is this relevant? Well, as many speakers, the three speakers before me have already said, we have in a very short period of time, in the case of agriculture over 70 years, focused solely on growing food without the consequences to the natural environment. And so in particular in sub-Saharan Africa, not only has the Green Revolution, the first one, failed because it looked at the major crops, rice, wheat, and maize, which are not grown or consumed in large amounts in sub-Saharan Africa, but also attempts to use Green Revolution type technologies, which demand huge amounts of water, are going to be difficult in semi-arid areas. And in the context of climate change, as the world gets hotter, we have to look at other options. So new technologies, new partners is clearly the way forward. So what have we learned from the Green Revolution lessons? That we can grow food, but we come to a plateau. And focusing largely on well-irrigated agricultural areas, which have optimal conditions, pushes out a majority of areas like the semi-arid areas or communities that don't grow the right kinds of crops. And yet, at the beginning of the 21st century, it is these forgotten areas that seem to be giving us potential for new agricultural and, more importantly, sustainable food system returns. So I'll talk first about millets. There are many marginal crops that were pushed out because they didn't fit the way in which we thought food should be produced in the mid-20th century. What we resulted is therefore less research, and the lack of research has also resulted in a lack of international interest and a loss of trade for these important crops. Furthermore, the communities that produce these crops have been regarded as, dare I say, backward or poverty-induced, and little has been done to improve the crops that are there. This has considerable implications, as I will show using 3 examples, for what we could do going forward to begin to directly address forgotten or less used crops, but also to think of 2 related groups, those of perennial crops as well as silvo-pastoral systems. So why the case of millets? Well, partly because that's what has been my focus for the last 4 years. I guess I could be called a self-styled millets messiah, but what we learn from millets is that they grow across the world. And thinking about COP26 and nations coming together, this is an opportunity for the temperate and the tropical regions to talk to each other. What millets do is threefold. They are 1, more able to withstand water stress. 2, are more able to manage climate extremities. 3rd, very importantly, they are gluten-free, which means that they are incredibly important as a health crop. And 4, associated, they're small grains, and therefore they are better nutritively because they don't lead to a sugar explosion in the body and therefore insulin floods, which cause adult diabetes. So lots of positive reasons, which doesn't mean that millets are now the focus. They should be. But what they do allow us to do is to think about returning to those forgotten crops, of which millets is my first. There are currently 6 types of millets. They're not a single family. Biologically, they don't belong to the same biological family. They are simply called millets because they're small grain. They're actually shrubs, and this takes us therefore from our classic idea of crops, which are currently thought of as those that are lower level. We've shrunk the dwarf crops. Originally, these grasses are tall, and they are grown across the world, as the previous slide shows. And what we found working with partners, particularly ICRISAT, partners in India, in states in which millets are grown, partners in Ethiopia and Gambia, which are looking to millets as possible solutions, is that by linking communities and the nutritive foods that they eat, which were previously forgotten, we could find new pathways which link local communities to sustainable solutions. This also would fit in terms of what the first speaker talked about, nature-based solutions using local adaptations rather than bringing in external alien species, which are more difficult to work with. Thirdly, it would recognize farmers, particularly small farmers, as having knowledge, something that was not regarded as core previously. Farming methods can be improved. That improves the supply side. It also increases awareness of nutrition and health, which reduces features like obesity, bringing a balance between human beings and their environment. This is not just social science research. It brings together agronomists, economists, anthropologists, and the academic literature on the natural sciences side is also beginning to engage with this. A recent paper in PNAS points out that core cereals do increase yields. And that's something that we need to understand, because at a time where yield increase is difficult, this is possible. But much more importantly, they are able to increase the yields because they are climate resilient. The bottom half of this slide is particularly important because it is arguing this is not just a better way of producing food, it also directly engages with reductions in greenhouse gas emissions. And so again, as the first speaker spoke about, the importance of diversifying crops links to the ability to reduce emissions. And because these are hardy crops, they also use less energy. So in addition to the social and ecological wins, there are specific climate-related wins. The paper also shows this across different parts of India. Our partners worked in Eastern India where millets are consumed. There's actually a state-level millets mission in India. And for those of you who might be Millet Messiah inclined, 2023 has now been declared to be the UN Year of the Millets. And so this might be something not just for COP26, but going forward, thinking through the decade, this being the UN decade for thinking about sustainable food systems. And you can see across all three, while water is the biggest increase in conservation, both GHG and energy are important additional features. This takes me to two other points or milestones that we might like to consider going forward. If millets being ecologically more robust is a possibility, why not look at other crops that may be even further down the role of what we call regenerative agriculture, the no tillage, the idea of not using the soil, not turning it over, which we know is one of the biggest causes of GHG emissions, is naked soil. So there has been work associated to our ideas of millets, which we could think about, which colleagues have been working on, academic colleagues, the perennial vegetable space. This is extremely important because these are crops that are not therefore removed from the soil, therefore the root system stays intact, it keeps the soil under cover, and they produce every year. Of course, there are some plants that we've moved from perennial use to annual use. And papers like this one, which came out last year in PLOS ONE, make the argument, and this is a wonderful paper because it's really the way forward. It collects a whole set of papers and a meta-analysis to look at which vegetables are currently being grown and which ones should. And clearly, we're only beginning to touch the tip of the iceberg because we only cultivate a few from the many types of perennial vegetables. And they argue, again, for us to think about changing our idea that crops, as I said, are knee length or below, and to think about the idea of vegetables being including plants. Again, the notion of vegetable and plant is quite an odd one because if you think about trees and plants and bamboos, they also produce important features of agriculture. And so they show in their paper that we could sequester far more carbon if we looked at the larger woody plants, the trees, the palms, and the bamboos. And this would allow us to think about these as important features. Their paper therefore shows that as a synthesis, we could be doing far more using perennial crops. This is not just a matter for aggregation of papers. What's interesting in the second paper by Chahal et al., there are a number of papers they've brought out in 2020, is taking this idea of perennial vegetables to anything that covers the soil. And so they've done a really interesting paper that is based on research in Canada. And as I said, just like millets, there are so many of these crops that can be compared across temperate and tropical to give us a better sense of what would be most suited to different ecological environments. And this paper not only shows, as the previous does, that cover crops would allow us to increase carbon sequestration, but they also calculate, very interestingly, the price. It was $20, they say, for 1 ton of carbon. It will increase by $10 every year. So if we're looking at the price for 2021, we're already hitting over $50. So here is a different way of thinking about compensation, which takes out actually the cost and therefore how one could relate that to carbon sequestration. And my third milestone, where I'll stop for a moment, is taking this biodiversity further, not just talking therefore of trees, but about thinking about multiple use of land for livelihoods. So silvopastoral systems are ones that use agriculture along with the growing of trees, but trees actually forming a wooded area. And one could add to that agro-silvopastoral, where the animals work with crops in such an environment. And this begins to resemble, therefore, what we would call a biome or an ecosystem, and therefore is moving more to what we call nature-based solutions. Sorry. And in this regard, again, a wonderful set of papers. And what's fascinating about these, I suppose, similar to what we've done on Tigris and Meti, is to bring academics from very different disciplines to think about the same problem. Nothing like a bunch of very clever heads working with different ideas to solve the same problem. And what they've done in relation to this work, and here I want to talk about these because these are two different papers from two different parts of the global south. This paper, which looks at Colombia, and again, the researchers come from the global north and south, is looking very specifically at silvopastoral systems to reduce degraded land. So this is not just existing functional ecosystems, but degraded lands, as well as better managed lands, and look at the difference in ability to increase carbon sequestration. And like we have done in Tigris and Milleti, I was very inspired to find that they've also taken on board local livelihoods and worked not just with the natural world, so we don't have this divide of science versus social science, but an integrated approach. And they're arguing that while GHGs can be reduced through carbon sequestration, this will not succeed without taking communities on board, particularly the different size of land holdings. Marginal farmers in particular are first often to fall out of any solution because their increased need for current income outweighs any other weights. And so they argue that even in the case of Colombia, where this has been done, unless land use change is also factored in, short-term sustainability in carbon sequestration can become undone. And so they argue that linking agriculture to the pastoral world, and this is interesting because the trade-off is no longer animals versus crops, that we could even think about animal husbandry becoming more effective by using this system. Another South American country, the case of Brazil, of course, much larger size agricultural holdings, the huge latifundias, but even here, again, very carefully looking across the process of agriculture. So here they have, if you like, a controlled experiment. The first is looking at pre-farm. They calculate the costs of agrochemicals, storage, transport, and then once the farming cycle occurs, the costs in relation to fertilizer and machinery use. And then they grow trees with across 8 different regions, and they calculate the costs and the returns to farmers. And once again, what they do find that it is possible to think of a silvopastoral system, in this case, agro-silvo system, where the planting of trees not only gives returns, but the number of trees grown on the experiments are far more than is needed to completely offset the carbon costs. And like the Chahal paper, the Torres et al. Paper also begins to calculate the possibility of voluntary markets. I emphasize this point because in the past, our entire narrative on carbon trading has been driven top-down, talking about how markets can be conceptualized. What is really powerful about these bottom-up solutions is this is how communities might want to work in markets. And I strongly recommend thinking, as we all do as a group of academics globally, as well as in our individual institutions, of thinking about working with farmers rather than telling farmers what to do. So going forward, my last point is much of what we're doing has inspired many of us to delve into new opportunities. And in keeping with IPCC's specialist report on climate change and land that came out in 2020, we are looking at a particular group, not by biological category, but by lack of recognition, the neglected and underutilized species, locally grown products, not traded, not only for their economic value, but much more so for their ability to carbon sequester and to reduce greenhouse gas emissions. And so very specific ecologies, like those in the Hindu Kush region, a mountainous region where a variety of crops, barley, millet, sorghum, wheat, taro, yam, and taros and yams are really important because these are crops that grow under the soil and they have cover, and they are very important for small and marginal farmers across from Southeast Asia all the way through into sub-Saharan Africa. And so this afternoon, as part of that, we are launching a new society across different geographies and disciplines called the Forgotten Crop Society. And our intention is precisely to work with communities that remember to use those crops, and then, like these excellent papers that have come out in the last 2 years, to work with researchers to ensure that we actually find realistic pathways to both capture and sequester carbon and to reduce greenhouse gas emissions. Thank you so much for your attention.
Shailaja, that was extraordinary. Our global patrimony of crop varieties, I think, is one of our definitions of our civilization, and is an extraordinary asset that's been built up by thousands of years. And I think now, more than ever, we need to cherish and look after that extraordinary heritage. So I will now refer to you from now on as the Millet Messiah, Shailaja. Thank you very much. And I want to join your Society for Forgotten Crops. I trained as a horticulturist and I was just loving that. Right. I'm just going to see whether we got any questions, quick questions, and then we'll go on to the general board. Shailaja, there's no specific questions. What I'll do, we'll go through to the panel discussion, if I may. But thank you very much. Right. I'm just going to open up the questions. Whilst I pull the questions up, I think, Shailaja, there's one thing I'm going to quickly ask you. Where do you see the convergence of restoration ecology and rangeland management in terms of these?
I got the first bit, restoration ecology. I didn't get the second.
Where do you see the convergence between restoration ecology, taking Nathalie's working landscapes and existing wild landscapes? You seem to be in a middle zone where ecological restoration and agriculture seem to be converging.
So I guess I would say I think it's regenerative, because I think a lot of areas have actually been denuded, degraded. And so we were having a talk 2 days ago, Giles and myself, Giles Allroyd from NIAB and myself at the Tropical Agriculture Association, the questions there. I remember Giles saying the same thing. If people are doing good stuff, work with what they're doing and try and find out where the gaps are. I think the reason we're doing this is because we are so aware that, 1.5 degrees and 2030 are both, inescapable, but they may escape from our grasp. And so unless we get down and do what is being done well, and we actually talk to researchers across the board who are doing stuff, we don't really have the luxury of, I'm going to do a randomized control trial and wait for 5 years and see what the solution is. The bus would have gone and the oil would have run dry and we won't know what to do. So sorry, that's my short answer at lunchtime on a Friday.
No, that's pretty good for a Friday lunchtime. We've got to be pragmatic, and it's that balance between caution and catastrophe, isn't it? And we're constantly.
But I would agree that while we're doing this, is the time then to classify, conceptualize while we're doing the work. I don't think they can be two separate exercises, and I think Nat made that point when she was talking about we got to work with corporates, we got to work with people who have, transparent reasons for why they're working and coming together. It is an ecosystem issue.
It is. So I'm going to follow up from that theme, and we've got a question from Katie Parker. Katie's asking, how much hope does the panel hold that policymakers and negotiators have sufficient awareness of the need for nature-based solutions and sufficient political will to drive the change at this year's COP, and I would say both COPs, the climate and the biodiversity? So, Nathalie, I'm going to start you off on that one, if I may.
I think there's huge awareness of this. I think awareness is growing all the time about, broadly speaking, that we need to work with natural ecosystems to support human societies in multiple ways, including climate change. I think we've seen a real shift in the last sort of 18 months or so, shift in the zeitgeist around that, the recognition that nature conservation isn't the sole responsibility of the conservation community, but all our responsibility. And so, the Treasury commissioned the Dasgupta review on the value of biodiversity. There's a real sense that there's a general, awareness that, for example, in the business community, emerging this narrative that's emerging around nature positive economies from the World Economic Forum, this recognition by the corporate sector that there are all these reputational, operational liability risks around continuing to under or not value nature and to not take accounts damage to the biosphere and climate in the supply chains. There's a lot of regulation that's coming. The voluntary carbon markets are booming. The problem is, there's great signs of recognition. And I've been involved in UNFCCC COPs for a few years now, and each year they get greener and greener and greener. And this year, nature is all over the COP. It's the one area where we might see some major advances. I think there's hope that there will be some, important things around nature and funding. Sustainable finance committed towards nature-based solutions. The problem is, as good as all that is, the flip side of that is there's a lot of confusion, as I said, about what counts. And the problem is there is a conflation of things like commercial forestry with climate solutions. There's this idea that somehow we can, plant a forest the size of the Amazon and everything will be okay when it it's abundantly clear from the science and other sources of evidence that that's not the case. So I think there's a real urgent need for us to really double down on what we mean by good, which is why I sort of highlighted that in my talk, and to make sure that all this investment is being channeled into projects with high integrity, both on the people, local communities, indigenous peoples aspect, as well as on the biodiversity front. But equally, there needs to be integrity in terms of the investors themselves, and we need to make sure that those investing in nature-based solutions are only doing so if they are also radically and credibly and verifiably decarbonising all aspects of their operations in a way that's commensurate with the size of the organisation and the impacts on the biosphere and the climate. So, I think there is that. And I think there is there's certainly a lot of the other shift that's happening is a lot more awareness in the public, a lot more activism around climate, around the biosphere, enormous amounts of pressure growing among consumers for wanting to do the right thing and buy the right product. So I'd say there is political will coming from that angle as well. So regulation, political. So it is all coming together, but it's a bit chaotic right now. We need to, I like what I've been hearing from colleagues about the needs for scientists and practitioners and policymakers to work together a lot more in a lot more coherent way. So, which is what's needed. Yeah, thanks.
It's almost as if we've been waiting for this convergence of interests and concerns for the last 25, 30 years. And now we're sort of going, oh my God, the time has come. We've got to get our act together and we've got to seize this opportunity.
Absolutely.
It's really an extraordinary position we're in. Damu, from your perspective, where do we stand? Is there enough information and commitment out there to make a change and to incorporate nature-based solutions into that change?
Well, I was hearing Nathalie and she said so many things. What came to my mind is that many people around the world are aware of the problems that we are having with the global warming. For me, what I get is even the governments are aware of it, but nobody wants to bell the cat. So, I really like what she said, and what you said is that we seem to be converging to a space wherein we are now ready to do, but are we finally going to do the work that's required to be done? Or are we again going to go beat around the bush and not do anything about it, just talk about it?
Yes.
So I'm skeptical about this part because we all talk about it, but nobody wants to do anything about it at the end of the day. It's only time will tell whether we survive or we go. That's the end of it.
Yes, I think it's that mobilization of public concern is part of this, because abstract academic papers generally don't sway politicians, but public discourse and public discussion and public concern has that ability. And I think an understanding of the cost of not doing anything is going to be extraordinarily important.
I had a look at some of if you look at right from the beginning of 1850s, when we started using steam engines, and the GDP is the way it's going up, the world has benefited a lot in terms of using fossil fuels. But how much of it we are giving it back to actually take care of it? Nothing is happening about it as of now. So we're still waiting for something, God knows what. Hopefully COP26 is what she's talking about, may change the entire stuff. And we may finally open up our eyes and start doing something about it. All the solutions over here, different things, but we need to get started somewhere in a major way.
Absolutely, absolutely. Brian, from your perspective, where do we stand? Is there the momentum?
I think the awareness is slowly increasing. We're first briefed the Blue Carbon Commission over half a decade ago. And at that time, kelp forests were not considered to be one of the coastal ecosystems that was, fixing that much carbon. But the awareness has slowly increased. And now I think we've established kelp forest as emerging blue carbon sinks because the storage is non-local, but it's something that still we can measure and should measure. So, there's Paul Hawkins publishing the Regeneration book in September. We think that's going to be very positive because it really raises to the fore not only terrestrial, but also marine ecosystems and carbon sinks. The subtitle of that book is We Have One Generation to Really Address This Issue. And I don't think people fully realize what 80% decarbonization means. It means 80% fewer flights, that 80% of our meetings need to be like this online rather than flying somewhere and doing something. Because of the carbon intensity. And that goes as well for our industrial activities and the rest. We need, climate disruption is inconvenient. We have to address that first. But then if we can decarbonize by 80%, I believe that terrestrial and marine ecosystem regeneration can bring us carbon negative. And that's really the opportunity, is to improve and regenerate the decimation that we've seen in marine kelp forests and associated fisheries. And they're equally large. I would say both the terrestrial and the marine side are really important. And there's enormous potential, but we have to move now, and we have one generation to get this right.
I think we've got one generation to get that right, and then 20 generations to sustain it.
That's a very good point.
And what I worry about is having the institutional longevity to keep these innovations rolling, to keep these cultural practices rolling. And this is a very interesting challenge for society. It's like looking after nuclear waste. How do we ensure that kelp farming, the seeding of the oceans, that the maintenance of forests to absorb carbon, the retention of minority crops and their genetic diversity keep going over the next 150 years, 200 years, to keep this, because we're not going to fix it in 10 years, but we're going to have to tackle it.
I am encouraged that the International Energy Agency has identified solar as being the cheapest source of electrical energy in history. And we believe that marine solar may ultimately be even less expensive. That is encouraging because as we develop more sustainable ways of manufacturing solar panels, we do see a way forward that is economically preferable as well in the long term. So there are a number of promising trends, but we ultimately need to be transparent about the carbon embedded in what we produce and what we use.
Great. Brian, thank you. I think this is fascinating. Please, we need some more questions, and I'm really looking for questions from everyone, not just the pale, male and stale members of the audience, but from the whole diversity. Shailaja.
I have a question, if I may, Mike.
Go on, please.
Part comment. I thoroughly enjoyed thinking about the oceans as, farms of the sea, and thinking through kelp. I mean, kelp is the equivalent of millets, right? I mean, for me, that was the thing. I was thinking, let's write this mega good story. I mean, I think John's been saying, John Fitzgerald in the chat about, it's when the IMF talk and others talk, which is what Brian said. Get them on board. I mean, for the forgotten society, crop society, we were just told that ICRISAT wants to join. Absolutely. If they're willing to do it differently, I'll go for it. I mean, I don't think name calling is going to solve the problem. I think we really have to get our hands dirty and also think tech. So I don't know, yes, Brian, am I completely barking up the wrong tree or the wrong kelp forest?
No, I think it's great, Shailaja. And I loved the forgotten millets, because we feel as though, 100,000 years ago, there's good evidence in the gene pool that, in fact, humans were eating seaweed and small fish, and all sorts of coastal kind of inputs. And so we think that there's an enormous opportunity there. And, we're very impressed by the UN FAO's work with the Planet Genetic Resources Treaty to ensure that grains like millets can be naturally crossbred in order to ensure enough biodiversity that subsistence farmers can grow these critical grains during times of climate disruption. And why couldn't we apply that to critical sorts of marine species, plant species as well? For example, macroalgae like kelp and red seaweeds. We need the biodiversity to enable this to work. And that Plant Genetic Resources Treaty, signed by dozens and dozens of countries, ensures that indigenous farmers have the right to breed a single species on a worldwide basis to ensure biodiversity. And this is really important for terrestrial farmers, and seaweed farmers are also farmers, and they're subsistence farmers, and they need the support as well. So this is the kind of thing that we need to do and really bring these forgotten grains back. There's 14,000 species of seaweed. I think we're using maybe 1 or 2 dozen right now. So there's just enormous amounts of development that can be done, and we need to really study this. And I'm looking forward to doing this on land and in the sea.
I think this is fascinating because we're looking at a new era of domestication. I've been looking at the selection of heat-tolerant corals for restoring coral reefs. And so they're looking at the Red Sea as a source of these heat-tolerant corals. Now we're looking at, here in Cambridgeshire, we're looking at, do we start selective breeding of sphagnum as a carbon crop? Are we looking at selection of high-performing kelp clones? So I think that model of the value of domestication that millet has shown us and is now going to be applied to these new domesticates and these new farming landscapes.
I have to share with you, there's even a tiny grain of a seagrass that has a small, very small grain, and it actually grows in the sea. And so, they just discovered this, and it's like, wow, could we be growing rice in the sea? And I think these discoveries are essential as we go forward. It turns out the seagrasses were land plants that went back to the ocean.
That's right.
And they're growing there. So it's an angiosperm. So it's wonderful to see these elements return naturally and be able to develop these further.
And what I see is that there's going to be lots of jobs attached to this as a new form of, as these new forms of agriculture generate. Now, for those of you that are on YouTube, please send messages in to us from your messaging system. I'm just going to open up, see if we've got some more questions. We have a question about plastic. Ocean plastics as a threat to kelp and buoyant flakes. So I'm going to throw that one first at Damu. Damu, ocean plastics, are they going to interfere with your research and get in the way?
It may not be interfering, because we're basically aiming to do the work in surface waters. So of course, you have microplastic also in the surface waters. It depends upon what kind of plastics you're mentioning about, big bags or the microplastic, because there's plenty of microplastic in the oceans. But the way we are planning the experiment is that once the bloom is formed, you can then get them to aggregate and get the entire thing to sink. And as I mentioned, the major aim is to get the carbon to sink to the bottom. So during the aggregation, we may actually also end up killing the plastic. So in terms of answering the question, the ocean plastic should not be a problem for this particular experiment.
Good. So, and similarly with kelp forest, Brian, what's your concern about plastics there?
Well, plastics are an important effect in the oceans. And fortunately, we have many people who are working on the plastics issue. I'll tell you, what really keeps me up at night is no fish in the ocean, because there are 3 billion people that rely upon the ocean for food security. And if we, we've decimated the fish populations. 90% of the big fish are gone from the ocean. They've been harvested. More than half of the fish biomass has been harvested in the last 30 years. And the question is, how do we sustain this? How do we actually regenerate the forage fisheries that have been lost? And so I hope that over time, we can get people to care about regeneration of fish populations in the ocean using habitat creation like kelp forest and seaweed forest regeneration. Once we can regenerate those populations, that'll be key. But the plastic's important, but I'd say no fish is probably 10 times more critical. And so we need to start there. And that's one reason we're putting so much effort into marine permaculture as a way to regenerate the ecosystem. At the same time, we're obtaining a sustainable yield. That's one of the design principles of permaculture, is to have a sustainable partial harvest, enough food for humanity and enough food for nature. That's kind of the principle that's helping to guide us.
Yeah, I think you're absolutely right. I think, and looking at fish as a co-benefit of this carbon crop, really important. We have a question from Damo Menon, and I think I'll throw this one at Shailaja. The question is, why don't we involve leading private sector actors from real economy in these debates? We should be having global corporates like Cargill, Louis Dreyfus, Mars, Olam in these discussions. And I would
I have no disagreement at all. I've spent much of my research career trying to get to talk to Monsanto, and they didn't want to talk to us. I think, however, the time might be there. If people are thinking about core business and their triple bottom line is not going to be there. For example, if there's not fish, or if we end up in a situation where you are trying to sell soybean feed across the country, if we are going to increasingly emit GHGs. So I think there's a logical reason, but in economics we call it timeframes. I think we have an acute dissonance, a cognitive dissonance between short-term returns and long-term returns. Yeah. And like I said, the idea that pastoralism is opposed to agriculture is a very late construction in science and social science. It's a stylized model we have based on intensive agriculture, which doesn't need to be there. Similarly, the idea that short-term gains cannot be used with a number of choices where you'd use the precautionary principle with the one that is least emitting from 6 choices might be something that we want to think about. So I don't think Cargill or any other company could not be part of a conversation, but that conversation really needs to be about ensuring that what are the red lines for all these players and what is it that they want to do when they're there? And if they agree that saving the planet's important, then the conversation should go forward.
I agree. I think this is happening. Brian, what's your reply on that?
Yes, well, I would say that Cargill's taken a fairly active role in helping to establish commodity markets for important seaweed products like carrageenan. And so I think in terms of establishing a market and helping to support that market, there is a good benefit. I think there's more that can be done in terms of upstream support, because the reality is, in a warming world, if we don't have irrigation, we're going to lose the eucumitoid seaweeds, which represent 30% of the total harvest of 29 million tons of seaweed each year. And so we're going to need to invest in irrigation infrastructure, solar irrigation, just as we use on land, we're going to need in the seas to keep these tropical seaweeds productive and continue that production. And so that's going to require investments up and down the sectors. And I think there's an opportunity for Cargill to step up and increase investments in that area, because fundamentally they stand to benefit. And in fact, these carrageenan processing downstream relies upon a continued supply of the seaweed. So we need to do more, but so far it's been a good start. I think we need to invest in the upstream infrastructure.
Great. Thank you. There's a question in from Professor Bascavira. Basca's asking, and this is, I'm going to throw this one at Damu. Would growing diatoms in the oceans help grow fish?
Yeah, I think I also read Basca's question in the chat section. I was about to answer that. The answer is yes, but it depends upon how we want to go about doing it. And I think I'll just take a little bit again. He also mentioned about new algae over there. And this is actually one guy, I mean, it's a company come out in Karnataka and Bangalore, wherein they come out with some nanoparticles, which is giving silica. Traditionally, they've been used I think they're using it in the sewage system to clean the sewage. It's having plenty of nitrate and phosphate, and they're using it to grow diatoms. And at the same time, the secondary aspect of it is that you can then use it for increasing the zooplankton, finally, and the fish population. So yes, I think diatoms can be used to grow the fish population, because eventually it's the herbivores which will feed on these, and finally you can get an increase in the fishing population. But doing it in the open ocean, we have to see what our aims are. I mean, fish is definitely important. Also emphasized by Brian that we have practically consumed a good amount of it from the natural systems. But then our primary aim here is to first sequester carbon. So we need to get it out first. And that's the reason I mentioned in my talk that over a period of time, we can also use such technologies to also harvest and get more fish. So I mean, so in a simplest way, yes, it can be used for getting more fish. But I think we should first focus on getting the carbon back. We should first focus on getting the system back to normal, and over a period of time, then go over to the fish part of it. It's unfortunate that whenever something new comes, we just jump on it without looking at the larger picture. We need to do that and then only see. But then it's very difficult. It's a competitive capitalistic world. So people just, something new comes in the market, they just want to make quick buck out of it. So we need to stand back and look at the larger aspect, larger picture to see if we want to use something, how do you go about using it so that everybody is benefiting? If the system is not there, then there's nothing much you can do after that.
So primarily capturing carbon, fish as a product down the line as a side product. Excellent. Brian, I think you wanted to follow up on that.
Yes, for us, people come for the carbon, but they stay for the regeneration. We see that the primary production with kelp is extremely important for food, feed, and fertilizer products. But secondly, the fish habitat is absolutely essential. And the habitat is created by the macroalgae. Microalgae also provide important food for herbivorous fishes. And so you get both the habitat and the food supplies. And keep in mind this, I think in David Attenborough's documentary, he discusses the 100 million square kilometers of mostly empty ocean. This is a place where we can have a degree of freedom that we didn't have previously. The land area is largely constrained either by existing agriculture or the need to preserve natural ecosystems and biodiversity. We have 100 million square kilometers of mostly empty ocean, and using less than 1% of one ocean, we can sustainably feed the world, we can regenerate life in the ocean, and we can sequester potentially gigatons of carbon. So it's an enormous degree of freedom by developing deep water systems such as the marine permaculture platforms we've been working on for the past half decade. It enables us to really provide the essential abundance of life in the ocean that will be needed to sustain humanity and nature for years to come.
And not just feed us, but also delight us.
Oh, so true.
Be part of that wonder that is nature. I mean, Nathalie said it earlier on, the nature-based solutions generate empathy with nature. I lived in Florida for a number of years, and the one piece of civic legislation that everyone took seriously was don't chop the mangroves down. You will get fined. Everything else was subject to negotiation, but you looked after the mangroves first.
So important.
Now, I've got a question, an anonymous attendee here. So how do you change public attitudes as to the economic impact of not using natural resources? For example, communities that rely on soya crops or others. So I'm going to just, how do you change? I'm just going to make sure we understand that. How do you change public attitudes? Yes. So how do you basically move from natural resources to those and depend more heavily on crops like soya? I think that's what the question's trying to say. Brian, are you responding to that, or is that a legacy hand?
No, it is an active one. So we work with a number of groups like Host 4C that are actually working with the seaweed farmers to create marine protected areas where they actually have the farmers themselves that are working, and the subsistence farmers become the defenders and the stakeholders of the marine protected area. And this combination is incredible because they have a sustainable harvest, and yet the protection and the biodiversity is increased. We see I read an article that said, the sharks that are swimming around a particular island historically were harvested, tragically for fish. But it turns out the ecotourism value of the shark could be measured in the millions of dollars. So when we get these higher values for that natural ecosystem, whether it's ecotourism or other kinds of biodiversity, and we value that, these higher values can be brought forward economically and provide sustainable livelihoods to the subsistence residents of those communities, whether it's subsistence seaweed farmers or on terrestrial environments. We see this as really important, and we need to bring these value chains for higher values of natural ecosystems to the fore.
And I think that's going to depend on us telling better stories about the food on the shelf at the supermarket.
Very true.
Yeah. Shailaja, you wanted to respond to this.
Absolutely. I think the two-part answer. One is communities tend to get stuck into a corner if there's only one thing they think they can produce, because the supply chain is working against them, and they're therefore, you know, stuffed in a corner. We have found, for example, in Maharashtra and Western India, where it's a semi-arid region and they're moving towards perennial grape cultivation, they've changed their idea from how much natural resource to measuring it, as Brian said, at a higher level. Literally each drop of water, what is the return on it? Because they've started to price water. If we can price water, then moving to pricing soil and then linking that to the greenhouse gas emissions in relation to naked soil is something that we can begin to talk about. And if you don't shoehorn communities into these difficult corners, they will respond other than the fight and flight response, as we would all do. Thank you.
There's a lot of wisdom there and experience over thousands of years that we can gain from. And I think it's interesting that talking to local farmers around here in Cambridgeshire, they're also looking at the crops that they need to sustain their business over the next 10, 20 years. When we're living in Florida, there are a few farmers experimenting with millet there. You'd be pleased to know that we're looking at as a grain crop. So your mission is spreading globally. I'm just going to, now we've got some more questions coming in. Great. We're getting a number of questions about diet. And if we're looking at, if people eat less meat, are they likely to eat more fish? Everyday people in the UK need very clear information on how they can help personally and how we get clear messages to the people. That's from Faye. I think that's a really valuable point. How do we take these discussions, and all of the speakers have looked at things that we use daily, whether it's timber, it's fish, it's landscapes. How do we get those messages out so people can make their decisions on their impact on climate, on their impact on biodiversity themselves with clear guidance? I'm going to start with Damu on that one, because you've got a huge number of Indian citizens who are right on the front line of sea level change and storm damage.
It's a very good question, because you're basically trying to change the public's perception of what their diet should be. And Indians weren't used to eating a lot of meat. They were used to eating fish, but now we eat a lot of meat at the same time. So it's a very tricky place to go. But basically, I feel one of the ways to tackle this is that you need to have more awareness in terms of if you're eating so much. For example, it's very clear that I think because of meat production, the greenhouse gas is somewhere around 14 to 15%. People are not aware of this, and we need to get this awareness in them. Number one. At the same time, if you are doing if you are going to really eat so much meat, then you need to find a mechanism of recycling it, which you do not have in place. As of now, we're just going with the market, and the market says that you need this particular thing. People go and rear it and get it done. So public awareness is the first way I believe we should go about. And then at the same time, you also need to make people aware of the advantages of eating more vegetarian food, at the same time having more non-vegetarian food. So that's something which I believe is something that only the culture can bring in, and it can be done only over a period of time by making people more aware of the advantages of what they're doing. Yeah, that's it.
That's very tricky, and I think that's people at the end of the day are counting their pennies and working out what they can afford. And it may be that we're also looking at the need for subsidies and incentives to make these moves for better health. Good
amount of subsidies going on if you're a farmer, whether you are a farmer, whether you're a person who's rearing chicken or even meat, you get subsidies. So people do jump in on those kind of discounts available to you, and they can try to cash in on that. And at the same time, there's a huge market for meat in India at the moment. But then people aren't much aware of what the impact it's going to have on the environment. So that needs to be really brought about in a major way. At least for India, I believe that's what needs to be done. And once people realize it, then that's one of the simplest ways of reducing that. And I believe quite a few people who are actually now trying to promote for vegetarian food. So if that happens, maybe slowly we'll come out of it.
Yep. I'm trying to be vegetarian and I fail about quite regularly. So that's my personal confession. It's something I've just got to deal with. Shailaja, what's your view on this?
I think it's a really good question. As I said, trade-offs are important, but false trade-offs have been problematic, and unpicking them is important. So I think what happens is, again, this diet that we think is traditional is only 70 years ago. I grew up with spam in London. Spam didn't exist before the Second World War, and yet
so
spam
sorry.
is something people reminisce about. My father-in-law is Australian, and when he was alive, he'd talk about doorsteps of butter because they didn't have butter during the war. So a lot of it is unpicking, and I was just typing to Faye before saying we want to know what communities value in eating, and then trying to see what trade-offs they can make. And often it's like, as you were saying, Mike, urban gardens. You take young children to urban gardens, they take those ideas home and ideas change. So I think understanding heritage, doesn't have to be an old idea. It doesn't have to be hundreds of years old. Some things are 20 years old. And therefore looking forward also the younger generation, what are the new things that they would like to inherit? So I think part of this is also an intergenerational conversation. To regard one group as higher in terms of knowledge is not helpful when you want people to change. So first learning what people want, then working with them to find better ways. And the thing I really enjoy in my work is collecting millets recipes. It brings people together. So, talk about it as community work.
The convening value of millets. That is going to be one of the themes of today. Brian, please.
Yes, well, I think we're looking forward with marine permaculture to not regenerate the production of seaweeds, but this fish habitat means that these sardines that are around me in the background here are going to be an enormous resource as we go forward. And historically, they've been so important for feeding the world. And so we see the opportunity to regenerate billions, if not trillions of sardines and anchovies and small fishes. And these small fishes are perhaps the most healthy of animal proteins. I've read that the only animal protein that's associated with longevity are small fishes because they actually are neuroprotective and they provide many nutrients and essential benefits. And so that with seaweed, I think is wonderful. I try to go with a mainly pescatarian diet myself, and small amounts of protein. You don't need more than like 50 or 100 grams of protein per day, and that some of that can be obtained from vegetarian sources. And so by moving towards this pescatarian diet and ensuring that we can regenerate the global populations of these forage fishes, we can ensure healthy humanity as well as healthy nature, because this is the base of the ecosystem, if you will, the trophic levels for game fish and even apex predators. So we see the huge opportunity to regenerate the ecosystems and regenerate healthy lifestyles at the same time, with moving towards a small fish pescatarian style of diet going forward.
So this could be a performance indicator of success, but it might be a horizon scanning problem. Millet cultivators that I know in East Africa have enormous problems of elephants and bush pig coming in and trampling the crop. Down the line, are whales going to be your friend, or are they going to be a nuisance?
They're enormous friends. It turns out, there could have been hundreds of times more whales pre-industrially than we have today based on the decimation. And a very important point is that the whales were an enormous reservoir of micronutrients, including iron, historically in the ocean, because the whale poop was absorbed by microalgae, and those microalgae were eaten by krill, and the krill was eaten by whales. So we had this biogenic storage of iron in the Southern Ocean that was essential to that ecosystem being highly productive. We need to regenerate that kind of biological reservoir of micronutrients and ensure they can be part of the solution. Even today, the whales love to come by the kelp forest off California, and they'll scour the seafloor next to the kelp forest. They love to hang out there. The marine mammals view the kelp forest as an oasis. I think Dory said it right in the Disney movie. Blue ocean kelp. Kelp is better, and then she found her parents in the kelp forest. So that was our marketing program right there.
That's it. We have ended the workshop on Disney. I think if we look at the baseline for world populations 1900, that's great. Take the baseline back to 1600, and then really interesting biomass issues come up on just how many whales our oceans could really support. I think it's fascinating. It's 2:00. I'm going to hand over now to Matt, the illustrator, who is going to sum up our discussions in graphic form. Matt, over to you.
Hi, can you guys see the screen?
Oh, look, yes.
Cool. Yeah, it's been a really interesting talk, and it's always a big challenge to try and put it all into kind of illustrative form. But yeah, I mean, it's available. I think this will all be available afterwards.
Brilliant. I would like a poster of that, please. I think all the speakers would like a poster of that. So, Sean, if we can sort that out, I think that's brilliant. And I love the idea that we've got a wheelbarrow in the middle of it, showing that this is about human interaction. It's about taking responsibility. It's about interacting with life, whether it's plankton in the Indian Ocean and the Arabian Sea that Damo is working with. It's like this new landscape, the restored kelps. It's looking at the forgotten crops. This has been a really inspiring session, and I really want to thank our speakers, and particularly Nathalie, who's left us, who really has been behind so much of the science of nature-based solutions. So please watch the space, come back for further events at the Centre for Climate Repair. There's very exciting talks coming up, particularly on polar ecosystems. And I look forward to seeing you there. Thank you very much, everyone. Take care.
Thank you.
Thanks, speakers. Brilliant.